593 valid square. So we are giving 4 points in a 2D space. Yeah, this is very important because it is just a 2D space, so it means we can use the 2D geometry to solve the problem. And we are having 4 points. Return true if the 4 points can become a square, otherwise we're gonna return false. So the coordinate will be xi and vi, and the input is not given in any order. So this means there's no order for this P1, P2, P3, and P4. A valid square has 4 equal sides with positive length and 4 equal angles. Yeah, we should know about that. So how should we solve the problem? Yeah, so if it is a valid square, so the 4 sides should be equal, and the 2 diagonals should also be equal. Yeah, so if this is side 1, 2, 3, and 4, so 1 should be equal to 2, equal to 3, and equal to 4, those sides. And also the diagonal 5 should be equal to diagonal 6. Yeah, if we meet this condition, so it's gonna be a square, otherwise we're gonna return a false. So now let's just get started. So we are going to permulate the points, because if it is a geometry problem, normally we can use the brute force. Yeah, otherwise it's gonna be really difficult. So we're gonna use the permutation in Python. So for ABCD in permutation, so we're gonna so for ABCD in permutations of P1, P2, P3, and P4. Yeah, because we don't know the position of the 4 points, so we have to permutate all the possible cases. So if there's one case that is true, so we're gonna return a true, otherwise we're gonna return false. Yeah. Now we're gonna use a check function. If check A, B, C, and D, we're gonna return true. Otherwise, we're gonna return false. Yeah. Now the problem becomes how can we solve this check function? So the check inside will be A, B, C, and D. Yeah. So we first take out each of the points. So it's gonna be x1, y1 should be equal to A. Yeah, let me just copy. Yeah. So similarly, x2, y2 should equal to B, and this is C, and this is D, and this is x3 and y3, and this is x4 and y4. Now we get 4 points. Yeah, we have just imagined the 4 points will be like this. So the 4 points will be like this. So yeah, because we permutate the 4 points, so this gonna be x1, y1, and this gonna be x2, y2, and this gonna be x3, y3, and this will be x4, y4. Yeah. Now we just need to check if those 4 sides are equal, or if and if those 2 diagonals are equal. Yeah, because currently we just imagine those 4 points have the fixed positions. We just need to check if it can become a square. Yeah. Now let's just check. So we're gonna prepare side 1 should be equal to, yeah, here I gonna use the square x2 minus x1 square plus y2 minus y1 square, because it doesn't matter, I don't need to get the exact size, but I can use the square x2 square. Yeah, normally for the side I need to use a square root, but I don't need it. As you know, if those 4 sides equal, their square should be also equal. If their square equal, so the square root of the side should also equal. Yeah, I just need to copy the code. Yeah, I just needed to change it to side 2, 3, and 4. So here be 3 minus 2, and this also gonna be 3 minus 2. This gonna be 4 minus 3, and here similarly 4 minus 3, and this one gonna be x4 minus s1 and y4 minus x1. Yeah, because the position is x1, x2, x3, and x4. So it will be like this. Yeah. And we need also to prepare a diagonal. So diagonal 1 should be equal to here. Let me just copy this one. Yeah, it should be x3 minus x1 and y3 minus x1. So here I made a mistake, x2 minus x1 and y2 minus x1. Yeah, and this gonna be 3, 2, 4, 3, 4, 1, and 3, 1. Yeah, let me just copy this line and prepare anti-diagonal, another diagonal. Let's make it a diagonal 2. So it's gonna be x4 minus x2, and similarly here gonna be x4 minus x2. Now we just need to check. Yeah, if side 1 equal to side 2 equal to side 3 equal to side 4. Yeah, and this side have to be a positive integer, otherwise it will not become a square. So if side 1 add, they are equal, and diagonal 1 add, and also for the diagonal, yeah, and diagonal 1 equal to diagonal 2. If we meet all those conditions, we're gonna return a true, otherwise we're gonna return false. Yeah. Now let me explain why we're gonna check if it must be a positive number and this diagonal must be a positive number. So there's gonna be some cases. So yeah, for example, if we have the first point x1 y1 and this is x2 y2, yeah, and then x3 will also be this point, x2 to x3, and here is x4 also to x2. So there is a duplicate of x2, x4, yeah, and here similarly for y4 and y2, and this is y1 and y3. Yeah, as you can see that there is a duplicate. This also meets the conditions, but the diagonal one, it is x1, x3, gonna become 0. So we have to check it must not be 0. Otherwise, it can have a just can become one line. It can be like this, or all the points will just have a duplicate, will become here. All the points will be here. So all the sides are equal, and all the diagonal also equal. But there is just one point. It always, for example, to be 0, 0. And of course, this is not a valid square. So we have to check the side 1 is positive and the diagonal 1 is positive. So this means all the diagonal and all the sides are positive. Yeah. Now let me just run it to check if it works. There's some mistakes. Yeah, I believe it's because there are too much coding. Yeah, normally this is not what I expected for my first time of coding, but I have to check if there is some typo. Yeah. So let me check. So for ABCD in permutations of that, if check, gonna return true. Otherwise, I'm gonna return false. So this is x1 to x4 and side 1. Yes, and side 2 and side 3, x4 minus x3, y4 minus y3. Yeah, so this is the mistake because I always copy there. It's really easy to make mistakes if you copy the line. Yeah, so here x4 minus x1, so y4 minus y1, and here also be y1, and this is y2. Yeah, because this is the distance between 2 points. I just copy the line and I've made a mistake. Now let me run it to check again. Yeah, it seems there's a still mistake. There might be something I didn't correct it yet. Yeah. Yeah, let me just check it again if there's some points I've missed. So yeah, this is a y1. This is some points I've missed. And now let me run it again. As you can see, now it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it's pretty fast and it passed all the testing cases. And the time complexity is n factorial. N is the number of points. Yeah, because there are like 4 points and there will be 16 permutations. And in the 16 permutations, for each one of them, we have to check it like this. So here, we make it constantly. Time complexity, make it all 1. Actually, there are so many calculations. Yeah, but we just make it all 1. So the time complexity is n factorial. And this n is 4. If n is a really big number, so it's gonna be a big number for n factorial if n is 20 or 30, but currently n is just 4. This means we can use the brute force to solve the problem. Thank you for watching. See you next time.